recording, and everything that's projected is being, okay, it's being recorded now. At the end of class, I'm going to send it to YouTube, and then it'll take a while for it to load there, and then when I get a break around 10:45 or 11:15, then I will upload that to a playlist. And I'll talk about the playlist in just a minute. Let me get the slide set up from the current slide. So, are you familiar with Blackboard? Okay. In Blackboard, just go over this for everybody because some of it's just gone up. When you go to the home page in Blackboard for this course, there's a whole huge series of blue tabs here that even go to the next page. But all the ones you need to know now are on usually the front page. The second or third tab, now I'm telling from the instructor viewpoint, I don't see your Blackboard page, so it may look a little different. But somewhere a second or third tab is one that says syllabus and instructor information or something like that. If you click on there, you'll get the syllabus for the course, and it's there. Should be updated. Everything should be there that needs to be there. The one I think directly below that says instructor info or something like that. That's where I put my locator card. When you click on that, you see the locator card, click on that. It picks up and you'll see when I'm on campus, off campus, in class, out of class, which campus I'm on, all 5 days a week. Okay, which class I'm in, which classroom I'm in. Okay, and then you go on down, near the bottom of that first screen, you'll see one that says class handouts and more, or something like that. If you click on there, there's where the bulk of the course is. The first thing that's on there is your research paper instructions, and so they're there. And then you'll see the PowerPoint slides for every section we could possibly do this term. Probably some we won't get to, but every one that we could possibly do, the PowerPoint slides are there. Okay, at the end of those, I put things like 4 or 5 links, web links, that either I have found or students have given me that they said they found useful in the course. Whether they're still useful or not, whether they're good, I noticed a couple of them when I was loading them go to the last edition of the book. They didn't have, the last time I looked, the current edition there, but there's very little change. So you should be able to get anything you need from those. So that's there. There's about, like I said, 4 or 5 of those. And then the last thing on there is one that says Math 112 YouTube videos. Okay, you click on that, you'll see an entire playlist. Now, a lot of those at the top of the playlist are from the last time I taught the course. I don't delete those until we cover that material again in this course. But I do delete them when they go. So you need to go to the bottom of the list. And what have we had? 4 classes so far. Today's the 5th. So starting somewhere there, the first one you see that says syllabus, that will be starting this term. And you can hear everything I said about the syllabus. You can see it. I can't remember how much we got done that first day. The next one says something about research paper instructions or something like that, and then probably also safety and other things like that. Finally, we got to covering math, and then we've only been in section 1.4. We should finish that today to go. But all those are there, and then if you want to look ahead, you can go to the top of the list, and you'll see the upcoming things there. But go to the bottom. So that's how you can find out everything that's done. Now, okay, I think that's probably enough to get you going. Any questions on anything we've done so far? And by the way, all of it's out there. Hopefully it's all correct. If you find something that's not correct, bring it to my attention. I'll try to fix it. Okay? Any questions? All right, where we left off last time was, past this, I don't know why we're back. Yeah, here we go. Domain of a function. We've already talked about this several times. Someone remind me, what is the domain of the function? Well, let's start over. What's a function? Oh boy, okay, it's been a long Labor Day weekend. Okay, what's a function? Relationship between two quantities. okay? Generally numeric, but they don't have to be, okay? The input set of those quantities is called the domain, all right, okay? The output set of those quantities is the range, because depending on what you choose from the domain, the function is the thing that operates on that choice of the domain to give you the output, which goes into the range, okay? Now, there's lots of relations like that between two quantities, two entities, or whatever. To be a function, for any one input, what must be true? One and only one output. If you had something you could put one input in but have three different outputs, not a function. A relation, sure, but not a function. To be a function, so the domain is a set of those inputs. The domain of a function can be described explicitly. Like I say, the people in this class could be the domain of a function, okay? That is an explicit description. Or it can be implied by the expression used to define the function, okay? So we'll see examples of both of those. The implied domain is a set of all real numbers for which the expression is defined, and you have to figure out whether it's defined or not. For instance, this function right here. F of x is equal to x squared. Let's see. Can you see this? Yeah, okay. It's equal to x squared, 1 over x squared minus 4. Okay? Now, time out. Anytime you have a function like this, your first assumption, and this is sort of implied, but it's not an implied domain. First assumption is all real numbers, unless there's some reason that you have to exclude some. Okay? Now, are there any real numbers you have to exclude from F there? Here's the thing to look for. Anytime you have a variable in the denominator, guess what a denominator can never be? 0. Exactly. I thought you were giving me the okay. Okay, no. All right. 0. Okay? Now, what would make that denominator 0? All right? All right. Let me show you how I do it. The book doesn't quite do it this way. This is the way I see best. Now, by the way, this computer I have is called a tablet computer, and it has an ionizing pen, which, if you've ever signed out at Home Depot, you know, in those ionizing pen, you know how that close to your signature that really looks. Yeah, that's what I'm dealing with here. Here's how I'd say this. What you just told me, here is the denominator. And we just said that denominator cannot equal 0. So x squared minus 4 cannot equal 0. That's exactly what I said explicitly, but wrote it in algebra speak, right? Okay. Now, what can you do to that inequality to figure out what values of x you have to exclude? The left-hand side particularly. What's the F word, folks? Oh, y'all forgotten it, huh? Factor it. Okay? I'm sorry, I hope that doesn't offend anyone. Okay, x will x squared minus 4 factor. How? Minus 2 or plus 2. Perfect. Difference of two perfect squares always factors as the sum in the different times the difference of their square roots. Okay? Now, looking at that, this tells you that x minus 2 cannot equal 0, right? Because if the product can't equal 0, that means neither one of them can be 0, right? That means add 2 to both sides, and you get x cannot equal negative 2. Okay? There's one excluded value implied by the expression. Okay? But the other one, yuck. I do not like this podium. There we go. Okay. The other one is x plus 2 cannot equal 0, right? If either one of those was equal to 0, the product's equal to 0, and then you violated what you just told me. The denominator can't be 0. This time you subtract 2 from both sides, and that gives you x cannot equal, that was a plus there, I can't read my writing. This is x cannot equal minus 2. So x can equal positive 2, x can equal negative 2. Okay? Because if it did either one of those, your denominator would be 0. All other values, perfectly okay. All real numbers except x can't be negative 2, x can't be positive 2. Everything to the left of negative 2, from negative infinity all the way up to negative 2, perfectly fine. From negative 2 to positive 2, perfectly fine. Anything from positive 2 to the right, perfectly fine. Okay? Just can't be those two numbers. Okay? So the implied domain here, consisting of all the real numbers x, other than x equal plus or minus 2. Those two values have to be excluded from the domain because division by 0, undefined. Can't do it, ever. Does that make sense? Okay. Now, can anyone think of another situation other than your variable in a denominator you'd have to exclude? If not, we'll get there. But I'm going to let everybody finish writing that needs to write. Okay? Anyone think of any other operation that you would have to exclude values from? Yes? Ah, very good. Anytime you see a radical, a square root symbol, anything that's inside that, if the variable's anywhere inside the house there, then that thing, the whole entity there, has to be, it can't be negative, so it has to be greater than or equal to 0. There is the second exception. That's the second place that you have to be excluded. There are others, and we'll get to them hopefully before the end of the term. You can't take the log of either 0 or a negative number. So logs would be, but we haven't even gotten to logs yet. Okay? You just burn them in the fireplace. Okay, anyone need this up a little longer? Okay? So, another type of a common type of implied domain is that used to avoid even roots of negative numbers. So, if you had this one, what immediately can you say there? As soon as you see that. What does x have to be? How do you say that mathematically, in math speak? Greater than or equal to 0. You can take the square root of 0. You can't take the square root of a negative 0.000000001. Can't do it. Okay? But you can take the square root of 0. And there they said it right below here. Okay? So as soon as you see that, and it's not just x, it's whatever is inside the house there. The implied domain. Okay, now, let's go back. They've introduced another way to say the domain. Let me scoot back here. Here we said this way. X can't equal plus or minus 2. That's how they expressed it right here. We just said it in two statements. They said it in one. They said other than. They're writing it all out. I like to say it just like this. Can't equal. That way, that's all I need. I don't need other than or not this or something. X cannot equal that. Okay? Here's two ways you can write that domain. There may be more, but here's two. One is what I call set notation. The set of all x's such that x is not equal to plus or minus 2. Okay? In other words, and some people actually write another sentence in there, or a little statement, x is a real number such that, so I just say the set of all x's such that, the vertical line means such that, x is not equal to plus or minus 2. That's one way to express it. The other way is what I did with my arm waving. Okay? And that's called interval notation. And what you do to think of this is picture your number line. Okay? All real numbers here. We'll put 0 somewhere in the middle, and we'll do 1, 2, 3, 4, 5, 6, 7, 8, and it goes on and on and on. Negative 1, 2, 3, 4, 5, 6, and goes on and on and on. Okay? Well, here's positive 2, and here is negative 2. I'm sorry, it's all over the place there. Okay, these two values it cannot be. So I'm going to put an open circle there, meaning you cannot use those two numbers. Those are the only numbers you can't use. Okay. You can use any number this way, you can use any number in between, and you can use any number that way. To positive infinity, negative infinity to positive infinity, except those two numbers. So here's how I express those in what they call interval notation. Starting at the far left over here, okay, I'm backwards, so far left over here, it's open parentheses, negative infinity, up to 2, or negative 2, but not including negative 2, okay? Now, parentheses means you don't include whatever's next to the parentheses. Since negative infinity is not even a number, that just means it goes on and on and on, you always use the parentheses with any infinity. The negative 2 here, you cannot include the negative 2. It's the open circle here. So you use the parentheses there. You union that. This is interval notation uses some of these. Actually, that's a set notation symbol, but union. And where do you start next? You start at negative 2, but you don't include it. So that's why you have the parentheses there. And you go all the way to where? Positive 2. And then you put a parentheses, because you can't use the 2. Then you put the union. A parentheses again, because you still can't use the 2. And it goes all the way to positive infinity, and you use the parentheses there because infinity is not a number. Okay? So it goes on and on and on. So that's the second way. This is what I call set notation. In fact, if you just put that, it's fine with me. I understand what you're talking about. The x cannot equal plus or minus 2. Or you can write it in set notation, set of all x's such that x can equal plus or minus 2. Or you can do interval notation, which to me takes a little bit longer to write. And here's the other issue I have with interval notation. In the past and in the future, we're going to express points on the Cartesian coordinate plane by ordered pairs that we put inside parentheses. And sometimes, especially if you didn't have the two outer things there, or the unions, if you had negative 2 to 2, I don't know whether that's a point, negative 2, 2, or if it's actually an interval. You have to get it from the context. This one, we know what it is. It's an interval. Okay? Now, the reason I showed that is on the next one, which we've already done. Okay? They showed this in just written form. X has to be greater than or equal to 0 like I did. That's perfectly fine. In set notation, that would be the set of all x's such that x is greater than or equal to 0. Seems like just extra writing, but it's set notation. Or there they did the interval notation. Now, what's different about that one from what we saw before? Okay, it has a greater than or equal that we didn't have in the other, in this notation. How about in this interval notation? What's different? A bracket, not a parentheses. What does that bracket mean? You include the 0. That's why, and as Ed was saying, the equal sign's there. We didn't have that before. If you include the endpoint, 0, then you put a bracket with it. Infinity never has a bracket. It's always in a parentheses. So it's any number from 0 all the way up. If you did your number line, with that being 0, okay, your x's would be including the 0, so I put a solid dot there, everything from there to the right, okay? from 0 to positive infinity, and because you do include the 0, you put a bracket. Does that make sense? Implied domain, there was nothing there that told us that except the square root symbol. That clued us in. In general, the domain of a function excludes values that would cause division by 0 or that result in the even root of a negative number. Now, why are they saying even root of a negative number? The cube root of negative 3, perfectly fine. The fifth root of negative 3, perfectly fine. The 17th root of negative 1, perfectly fine. The square root, the fourth root, the sixth root, any even root of a negative number, not perfectly fine. Those are the ones you exclude. If you had the index for the radical, and here's something a little bizarre. Anytime you don't see a coefficient for a variable, what do you understand it to be? 1. Anytime you don't see an exponent of a variable, what do you assume it to be? 1. Anytime you don't see the index of a radical, what do you assume it to be? 2. Okay, yes. If you had an index there, give me a number, any number. 4. That would mean the fourth root of x, okay? Would you have to do the same thing for it? Yes, you would, because it's even. If you don't see the index, you understand it be the 2. That's the one place, and probably the only place in math I know that's the case. Otherwise, if you don't see a coefficient or an exponent, you assume it's a 1. But here, for an index or a radical, you assume it's 2. Okay. All right. I think we beat that to death, right? All right, let's do some. Find the domain of each of these functions. Okay? Function A. The domain is a set. So we're going to define this domain with set notation. What are the elements of the set of that function? Anyone tell me? Okay. Help me somebody. So, okay, -3, -1, 0, 2, and 4. Okay? That basically is an explicit domain. The function told you exactly the values that would be in the domain. That's an explicit domain. Okay? When you have a set, and these are ordered pairs, those are not intervals, okay? Ordered pairs now, things in parentheses, ordered pairs, not intervals. Okay? That says this f is a set, the function f is a set of all ordered pairs, of these ordered pairs, -3, 0, -1, 4, 0, 2, 2, 2, and 4, -1. So the domain, the only values that you can put in the input are the first value of each of those ordered pairs. Make sense? Explicit domain. How about this one? What's your domain? G of x is equal to 1 over x plus 5.
You got to equal to 0, or you got to add it to 0.
Okay. You're sort of on the mark. What about 0?
Like, x plus 5 equals 0.
Cannot equal 0. You got it. Okay. X plus 5 cannot equal 0 because that's in the denominator. Now, the book does it another way and puts except that, blah, 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 other than, or something like this. To me, this is the most direct way. How do we solve that inequality? Okay. Subtract 5 from both sides, and that gives you x cannot equal -5. Every other value of x is perfectly hunky-dory, okay, except -5. So that, to me, is a decent way to do it. If I could read my inequality sign there, let me clean that up a little bit, especially if you're trying to copy. Say, what in the world is that mess, okay? Cannot equal -5. You could express that in set notation. The set of all x is such that x is not equal to -5. Or someone tell me how to write that in interval notation. Where does it start? negative infinity, so you precede that by parentheses, up to negative 5, close parentheses, union, parentheses, negative 5, to infinity, parentheses. Perfect, perfect, perfect. Every number in the world except negative 5. Okay? Now, here's another one. Now, they didn't mention this before. They kind of hinted at it, but not directly. The volume of a sphere. Here is a formula, an equation for the volume of a sphere. V is equal to 4/3 pi r cubed. What in the world is pi? It's a number, an irrational number. Has nothing to do with gender, by the way. Just irrational number, and that irrational number means it's 3.14159, blah, 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 and it goes on and on and on and on and on, never ending and never repeating a pattern. It doesn't repeat numbers, it doesn't repeat a pattern, it goes on indefinitely. That's an irrational number. Okay? So it's a number. Don't worry about it. It's a number. What is r? The radius of the sphere. There's your variable. Now, which of those, what variables do you see then? V and r. Which one of those is your independent variable? Second? Radius, exactly. And the dependent variable? The volume. Okay? So which of those would make up your domain values? The radius, exactly. Give me an r, I'll give you the volume. Okay? So, here's the deal. Volume, and this is a sphere, a ball, okay, a globe, a bubble, okay, that's a sphere, okay. What are the acceptable values for the radius of a sphere? Okay, exactly. He just said positive. R has to be greater than 0. Okay, that's the domain. Why? Show me a sphere with radius 0. It's nothing. It's not one. Nothing's there. Okay, so it can't be a sphere. And do this one for me. Draw me one with a negative radius. I want to see it. You can't do it. You have to have a positive radius to draw a sphere, right? So that is your domain of this. Now that's one way to put it. Or you could say the set of all r such that r is greater than 0. Okay? Can't be equal to 0. How would you express that in interval notation? Okay. You can't use any of those negative numbers. Okay. But what do we precede the 0 by? Parentheses, 0 to positive infinity. Well, really, we can't go to positive infinity, but yeah, you could. Any number. Pick a number. The universe, okay? Universe squared. I don't know, you know. Any huge, huge number. Okay, how about h? Okay, I'm sorry. The D part of the example. That's h of x. What are the limitations or values of its domain? Any limitations? What's the key ingredient to look at there? The radical sign? Is that what I'm hearing? Am I hearing so bad? Okay, and what can you say about it? What can go inside a radical? Only, say again? Positive or equal to 0. Okay, so in other words, what's inside the radical, and what is inside the radical? 4 minus 3x has to be, say again? Greater than or equal to 0. Perfect. Okay, now we have to solve that inequality. Been a while. Can we do this? I think so. How do we solve that inequality? We're solving for x, by the way. Subtract 4 from both sides. That's perfectly legal. Okay? Time out here. Anytime you have a directional inequality, you can add or subtract positive or negative numbers from both sides of that. You do not change the sign or the direction, the meaning of that inequality. So leave that alone. Just bring it down. This adds to 0. This will be a negative 3x is greater than or equal to negative 4. Okay, good so far. What's next? Divide by negative 3. Divide both sides of the inequality by negative 3. Time out. When you multiply or divide a directional inequality, that's greater than, less than, greater than, equal to, less than or equal to, one with that, by a positive number, multiplying or dividing by a positive number, you do not change the direction of your inequality. It stays the same. But when you multiply or divide a directional inequality by a negative number, what happens? You have to flip the inequality. So this becomes, because that's a negative number, x is less than or equal to 4/3. Perfect. That to me is an okay way of expressing the domain. If you want it in set notation, that would be what? The set of all x's such that x is less than or equal to 4/3. There are other things you could put in there. How about interval notation? What would that be?
Infinity.
Which one? Negative infinity, because this is anything less than 4/3. Comma. 4/3. Close bracket, because of the equal sign there. Anytime you're including that endpoint, you use a bracket. So there it is in interval notation. Less than or equal to 4/3. It can be equal to and anything to the left of 4/3. Got to make sure I'm facing in the right direction. Okay. Does that make sense? Everybody? Okay. All right, to erase. You're going to see all the answers show up later, but if you want to get what I wrote, you can. Because I go through a few steps that they don't always do in the book. They just sometimes, this is the answer, so they don't show you how they got it. All right, to erase. Okay. So let's see, the first one. The domain of that first function, f, consists of the first coordinates of the set of ordered pairs. Because the first is always the input, the second is the output. And so you got the input values, and the domain is a set, so the set of -3, -1, 0, 2, 4. Okay? Just a little hint, I guess. Most of the time, the back of the book and probably your answer keys or things like this, and if you are doing WebAssign, oh, and by the way, let me say this again, for new people and also anyone who wasn't here last time, your class code to access your ebook and to get a WebAssign and all that kind of stuff is this: Lawson.al for this course 2704, and in the email they sent me, they had a space there, and it was 2966. Okay, let me find out. Did anyone use this? Did it work? Anybody? It did? All right. Were you able to access WebAssign too? I don't know if you tried, but you didn't even try. Yeah, but that's all you really need in this course. But you now have access to everything. WebAssign, even though I don't like the way they look for one and only one answers, for instance, if they wanted it in set notation and you put it in interval notation, they say wrong, but not wrong. It's just that that's not the one they're looking for. and there's no way of telling it, or vice versa. If they want an interval notation, you put it in set notation, say wrong answer, and it would be wrong. Okay, that bugs me about WebAssign. But WebAssign does have great tutorials, I understand. Now, someone told me in one of the classes, don't do their one-on-one tutorial. Well, they said sometimes it will take you hours to get a one-to-one person. They say they have it available, personal tutoring, but they said sometime it'll be hours before now. Have you experienced that? Okay. So I didn't know that. I thought they were pretty good at that, but they're not. Okay. I guess depending on what time of day you choose, you might be able to get it better than others. So anyway, that's your WebAssign or your access code for Cengage Unlimited. Okay. Should give you everything. Okay, so there's the first one. The B one. Excluding the x values that yield 0 in the denominator, the domain of G is a set of all real numbers x except x equal -5. So you see, this is how they say it. That whole set of words there, domain of G is bored, okay? There they write it all out with words. Whereas saying, using the set notation like they did above, brace, set of all x, such that x is not equal to -5, just a lot more concise way of writing it. Same answer, but you see if they're looking for this and you write it the other way on WebAssign, they'll say wrong answer, but it's right, okay? And you never can tell which way they're what they're looking for. Here's the C one. Because the function represents the volume of a sphere, the radius must be positive. You can't have a negative radius in it. And this goes for lengths too. If it says the length of a rectangle, blah, 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 and you're looking for the length, guess what? Draw me a rectangle with a negative length. Show me one, okay? I want to see it, okay? You can't do it. Or a 0 length, that's a straight line, okay, or something like that. Okay, so R must be positive. There they wrote out the answer, okay? And then they say, so the domain must be the set of all real numbers, R such that. So you see that's the same thing I did before, except I put the set, the curly cues, they call them braces, brace, R, such that is the vertical line, R greater than 0, close the brace. Much more concise way of writing set notation than writing all those words. Okay, move on to D. Function is defined only for values for which 4 minus 3x greater than or equal to 0. Exactly what we said, and then they just said, by solving the inequality, you can conclude that this. They didn't show you how to solve the inequality, they just said doing it. If you didn't know that rule about flipping the sign when you divide by a negative number, you say, how did they get that thing swapped, flipped, changed, okay? Hopefully you know now, okay? You probably knew before, okay? And then the last one. Oh, so the domain is this. So this time they write it in interval notation. Perfectly fine, but if this is WebAssign, how do you know what they're going to pop up with next, okay? This one's in interval notation just like we did. Open parentheses, negative infinity to 4/3, close bracket, because it includes the endpoint. The equal sign is there. And then finally, oh, that was all. There were only 4. In example 7c, note that the domain of a function may be implied not by location of the variable, like in the denominator in a radical, but implied because it's a physical quantity. Can't be negative, okay? So that equation there, you'd have to reason to restrict R to positive values. If that was y is equal to 4/3 pi x cubed, but it didn't say it's the volume of a sphere, then you'd say all real numbers, because there's nothing to restrict it. As soon as you say it's the volume of a sphere, you have to have only positive values for the radius. Okay? All right. Now, by the way, and I'll say this for the new person, but remind anyone who wasn't here before that may or may not have heard me say it, every example they have in the book, like the one we just did with those 4, followed by a checkpoint. Okay? This checkpoint is a similar type situation, okay, very similar to that, only different numbers, different values and stuff, and it's asking for about the same thing, but then it says, if you, and to me, especially if this is sort of new to you or you're rusty at it, as soon as you get out of class and have time, like if you don't have another class right after this one, next time you have any free time, try to do the checkpoints first. Before you do homework, do the checkpoints, because we've done them just like it in class. So try to do the checkpoints, and if you can't figure out the checkpoints, then you can go to, and you see right next to checkpoint, audio video solution in English and Spanish at larsonprecalculus.com. So this author has 3 absolutely free websites that you don't need an access code, you don't need to even buy the book, you don't need anything. You can use, anyone can go out there and see them. They don't make any sense to them. And this is larsonprecalculus.com. That's for the checkpoints. Your calcchat.com for your homework exercises, and then a few of those have calcview.com, which really goes into big detail on a few of those. Okay, so let's move on to applications. You work in the marketing department of a soft drink company, and you're experimenting with a new can for iced tea that is slightly narrower and taller than the standard can. You've probably seen things like this happen before. For your experimental can, and this is a key thing here, for your experimental can, the ratio of the height to the radius is 4. Now, as soon as you read something like that, okay, since I'm running my mouth up here, I'm not keeping up with time, so let me put that up there. Okay. As soon as you see that sentence right there, that phrase, that clause, no, whatever, okay. The ratio, what does a ratio mean? It's a comparison of two numbers in a division sense. So when you see ratio, the ratio of the height, that's h, to the radius, that's r, that means the h divided by r. That's the ratio of height to ratio. Is, how do you translate is? What we're doing now is translating English to math, to algebra. What is? Equal to, exactly, 4. There is your key for this problem. The ratio of the height to the radius of this new can is 4. And you see there, they wrote it right there, but they wrote it in real little print. But I wanted you to see that's how you translate this clause right there into math speak, algebra. All right. Now, here it says, write the volume of the can as a function of the radius r. Okay, now that's going to require a little more dealing here. You're looking for volume as a function of the radius r. Well, does anyone know what the volume of a right circular cylinder is? If you don't, let me tell you. It's the base times the height. Okay. Now, when I do a capital B there for base, that actually means the area of the base times the height. Does anyone know what the base of a right circular can is? Circular can. A circle. That's what the base is, a circle. What's the area of a circle? And you're starting to give it to me, I think. Pi. Say again? Pi radius squared. Pi r squared times h. There is the volume of a right circular cylinder. But that's in terms of, now pi is what? A number. Okay to have numbers in there. R is radius, h is height. But guess what? They want the volume of the can as a function of radius alone, not height. So how can we get the h into r? Look at our equation there, the key here. If you multiply both sides of this by R, that's legal in most states, right? Okay? Then your R's go out here, and you have H is equal to 4R. So now you can plug that in for H, pi R squared times 4R. And what would that be? It's just rewriting it, rearranging it. 4 pi, there's your numbers, R cubed. V is equal to, I don't need another set of equal signs, do I? Okay. V is equal to 4/3 pi R cubed. Okay? Do you see that? You have now written the volume of the can that you knew. And by the way, if you didn't know that the volume was the base times the height, you probably should have, but you didn't. You can go to the, I always have to figure out where it is. In this book, it's the back of the book. Yes, there it is. Back of the book, here, inside the page there, right circular cylinder, volume is pi R squared H. Area of the base, circle, times H. Okay. So it's back there. You didn't have to know it or memorize it. You could look it up. Okay? Always legal. Okay. Second? All right. Now, the B part says find the volume of the can as a function of height. Okay? We go right back to where we started. V is equal to pi R squared H. Well, we got one H in there, but we got to get those R's in terms of H's. And how could we do that? Go back to our key here. In fact, you just lose what we just did. If you want to know R in terms of H, just divide both sides by 4. And there we have it. R is equal to H over 4. So now, that's what we plug in. We have pi times, and R is H over 4, so it'd be H over 4 squared times H, right? H that was already there. And what does that give us? Anybody? Pi. Okay, I like pi. Okay. Say again? Okay. Do you please excuse my dear Aunt Sally. Remember, that would be H squared over 16 times H. And that would be pi over 16. There's your number part, H cubed. Yeah, that's it. So there's your volume as a function of H alone. Okay? Now this is jumping ahead, or maybe going backwards or somewhere. See, what they're asking for in A here is V as a function of R, meaning no H's in there. And down here they're asking V as a function of H with no R's in there. They didn't write that in the notation, but that's really what they're looking for here. Okay. Does that make sense? Kind of, a little bit, sort of. Not at all. Make sense? Okay. People still writing, I'll give you a chance. Sorry, I'm all over the page, but they don't give me a lot of white room here, but I thought it was good to keep that picture and the variables there. Isn't algebra fun? You can do so much with it. Okay. I'm pretty sure the next example is not going to be on the slide set, but let me see if it is. Everybody finished? Okay. Oh, here's the solution. So you get to see how they did it, which I think is very similar. First they say the volume is a function of R. There they use that notation, except they didn't use it correctly because they have is equal to pi, which is fine, that's just a number, R squared H. Well, you have an R and an H there. So what they have is V as a function of R and H. If you're writing that technically correct, this would be V as a function of R comma H. Two independent variables, except they're both not independent. That ratio that we had, that makes them dependent on one another. So what we do first is, and they just out of the blue say H is equal to 4R. It didn't show you where you got it. Of course, you know now, but seems a little mystery meat here. So just to rearrange it, they put the numbers together, 4 pi, and then the variables together, R cubed. Now this is equal, both of these is V as a function of R alone. That top one was a function of R and H. We need it as a function of R. That's just being picky on the nomenclature. Okay, so that's how we got that. And then the second one, to get V as a function of H alone, though what they have here is again V as a function of R and H, but you want a function of H alone, then you write that R is equal to H over 4, which you get from that same ratio. You just take another step on it, and you get R is equal to H over 4. Plug that in for the R, and you get pi times H over 4 squared times H. And without telling you exactly how, they immediately go to the answer of pi. And here's the other place where this just really teased me off. If this was something that they had in WebAssign, and they wanted the answer expressed like that, whereas we expressed, or I expressed it as pi over 16 times H cubed, they would say, wrong answer. And then you're trying like crazy to figure out what you did wrong. You did nothing wrong. It's an absolutely correct answer. It's just written in a different form. So, kind of drives me nuts sometimes. That's why I don't use WebAssign. Not that it's not a good package, but it has these flaws in it that sort of drive me nuts. I don't like to be nuts any more than I am. Okay. Which is pretty far along. Okay. All right. Any questions? You folks still writing? It's the same thing we did before, only they skipped a few steps. This at the end, from this point on, this is V as a function of H. Not of R and H, but just H. Okay. And most of the time, I like to have coefficients in front, variables next. It's okay, perfectly all right to put them as just a one fractional form. That's perfectly fine. Okay. Let's see. Whoa, they don't have example 9, do they? And I can't think of any place. Let's see. Yeah, this will be a good place to do example 9. Let's clear the screen here. All right. Let's do example 9 here. How are we doing? We've got 2 minutes to do example 9. What you think? Not very likely, is it? Well, wait, no, it's more than 2 minutes. My watch is a little fast.
We got 5 minutes.
5 minutes. Let's see if we can get example 9. The path of a baseball. A batter hits a baseball at a point 3 feet above the ground. Is that pretty reasonable? Swing, I'm left-handed. Swinging, and I don't hit at all well. Swinging 3 feet above the ground would be right about waist high. Yes, if he hits it right in a sweet spot, it's going to go, okay? If he hits it, or she hits it, okay? Batter hits a baseball at a point 3 feet above the ground at a velocity of 100 feet per second, that's pretty fast, at an angle of 45 degrees. The path of the baseball is given by this function. Now they just pull this function out of the air, and it's true. F of x is equal to negative 0.0032 x squared plus x plus 3. Now, you don't need to know where that came from. I'll give you a few hints. Okay? Now, by the way, the x here is the distance from home plate. Okay, horizontal distance from home plate in feet where he first struck the ball, and the f of x is the height of the ball. Once he hit it, it's taking off. Now, when x is equal to 0, where's the ball? Right over home plate, right on the bat, and where is it? 3 feet above the ground. So when x equals 0, yes, 3. That makes sense because he hit it 3 feet above the ground. Okay? Now, remember, okay. Now, this is just a little from physics. You don't need to know this. But this form, this has to do with the acceleration of the ball. And once the ball left contact with the bat has no more acceleration on the ball. It changed its momentum to begin with, so yeah, it accelerated the ball. But once it leaves the bat, no more influence. It's done all it can. From that point on, the only acceleration on that ball is gravity pulling it straight down. Okay? And this is in feet. Okay? So what we're dealing with is 32 feet per second squared. That's the acceleration due to gravity in the U.S. customary system. That's for the 32. Now, where do all those zeros come from? Well, remember we were 100 feet per second was the speed of the ball. This had to do with the speed. Since the coefficient is 1 here, you did 1 over 100. But when you squared that, you got 1 over 100 squared. That has your 4 decimal points. That's where that came from. And 3 is the height of the ball. So that took all the time we had, wasn't it? No, we got a little more. Okay, so that's the equation. Okay? The question is, will the baseball clear a 10-foot fence located 300 feet from home plate? I don't think we're going to have time, will we? Okay? So we'll pick up here next time. We'll go path of a baseball next time. Okay. I'll try to remember not to go through all that mess again, and we'll just pick up and go. Let me give you homework exercises. Now, I know you were waiting for that. We're almost through with 1.4 finally, but we'll get there. Okay, either 5 or 7 or both. Both of those are at calcchat.com. 7's at calcview. Do number 9, it's at calcchat. Do any of the odds 11 through 17. They're all at calcchat. 11's at calcview. And by the way, I've given all these to you before. I'm just repeating those. Any of the odds 19 through 29. They're all at calcchat. 21's at calcview. Do either 31 or 33 or both. They're both at calcchat. Any of the odds 35 to 41. They're all at calcchat. 37's at calcview. Do either 43 or 45. They're both at calcchat. 43's at calcview. Do either 47 or 49. They're both at calcchat. 49's at 47 through 55. They're all at calcchat. 49's at calcview. Do 57. And any or 59. They're both at calcchat, neither at calcview. Once we do the next example, you'll be ready for 61. We'll wrap this up hopefully next time. All right, any questions? Yes? Okay, wait. Okay, 31 or 33, is that where? Okay. Okay, then any of the odds 35 to 41, and then 43 or 45. 35, okay. 31 or 33, that was one group. Any of the odds 35 to 41. Okay. Then 43 or 45, or both. 47 or 49, or both. Oh, I'm sorry. 47 through 55. Yeah, 47 to 55. And then either 57 or 59, or both. All right, glad to.
This is on page 44, right?
That's on page 44, 45, and then on to 46. Yeah. And we'll be through with this section very soon. This is just about the most important section so far, because this is introducing everything. All right, good deal. Yes. I can't hear you.
Do we turn in e-paper to you or keep it?
Okay. If you're having trouble with them, bring them to me, and we'll try to figure out where the problem came.
Okay.
But you see, try looking at the answers in the back. If you get those, you have no problem. If you didn't get those, then try CalcChat.com or CalcView if that's the one you're having
So
problems
maybe we
with.
can keep them at notes.
Yeah, exactly. Yeah.
Okay.
So then if you have questions, come see me.
Yes,
Yeah.
sir.
Yes, ma'am. Hey.
Okay, so do I need WebAssign or I just need the book?
You don't have to have WebAssign. The book is fine. Now, you know about this new thing they call Cengage Unlimited. Is this the... Okay. What's your major?
Radiology.
Radiology. So you probably won't be taking trig, will you?
No.
Okay. So this is the last math you'll be taking here at Lawson. Okay. It's up to you then whether you... now, if you're taking other courses that also use Cengage books, then the cheapest way to go is this thing they call Cengage Unlimited, which you buy the code in the bookstore, and then that's $119 for this term. There's another price if you do both terms, another if you do 2 years. So there's various pricing there. It's on the syllabus, by the way. But even if it's just this book for, what is it, $119, this book, unless you find it online somewhere, used or something like that, huh?
See you there on today.
Okay, yeah. Then the odds are it's going to be cheaper for you to go that way. But if you can find it online or have a friend who has already used the book and you can either borrow from them or buy it real cheaply, then that may be the better. You don't have to do that way. If you can get a copy of the book, go for it. But if you do the Cengage Unlimited, they give you an electronic copy, in other words, an e-book. And that's what that code does. Once you paid the thing, and when you get your receipt, there's a code on there. You have to hang on to that. And then this code, those are the two things you enter, and you get free access to your book. Okay. And if you actually want a physical copy, you can then go to the bookstore and rent a book from them for $8. So real cheap. But if you can get one cheaper somewhere else, that's fine. Even if you go to earlier edition, very little has changed. Okay. So.
All right, thank you.
Okay.